Welcome to this video on most commonly asked Java interview questions by Intellipaat. If you have clicked on this video, there is a high chance that you are already appearing for placement drives. And most often you are being asked interview questions revolving around Java programming language. I mean, it's natural because if you want to become a software engineer or a full stack developer, you have to know Java inside out. Even if you're appearing for interviews at MNCs, you will most often find yourself preparing for DSA with either Java or C++. And there's a logic behind that. And that logic is that every enterprise app is being developed by Java itself. Okay, now that we know how important Java is from an interview perspective, let's understand how this video can help you prepare and get the jobs. While preparing for my placement, I focused on Java as my main programming language. Based on my interview experience and feedback from other Intellipaat learners, I have put together a list of 30 most commonly asked Java interview questions. This list should help you review important Java topics and get ready for your next interview. So guys, keep your notes handy and let's start with the first set of the basic icebreaker Java interview questions. Moving ahead with the basic sets of questions. Question number 1. What is Java and why is it not considered a pure object-oriented programming language? Java is a class-based object-oriented programming language designed for simplicity and portability. Its key feature, write once and run anywhere, means that you can compile Java code and it can run on any platform that supports Java without recompiling. This makes Java a popular choice for enterprise application due to its robustness, security and ease of use. However, Java isn't a pure object-oriented programming language. Why? Because in Java, not everything is an object. Imagine you have a basic element like numbers and letters. Java treats them differently. Instead of being object, they are primitive like int for numbers or char for letters. You can manipulate them without wrapping them in objects. Another reason is the use of the static keyword. Static method or variable can be accessed without creating an object of the class, which breaks the object-oriented principle that everything should be done through objects. While Java offers wrapper classes like integer and float to convert primitive into objects, it still allows direct operation on primitives, which is why it is not fully object-oriented programming language. Moving ahead with our next question, which is explain the key components involved in running a Java program. Let's start by understanding how Java gets compiled and then break it down through the different phases, JVM, JRE and JDK. When you write a Java program, you first create a Java source file like example.java. This source file needs to be compiled before it can run, and Java uses a multi-step process. Firstly, let's talk about compilation. The Java compiler, a part of JDK, takes your .java source file and turns into bytecode. This bytecode is stored in .class file, like in our case, it is example.class. The bytecode is platform independent, meaning it can run on any system. Once the compilation is done, let's see the execution. Now that bytecode is ready, it can be run. And this is where the JVM or Java Virtual Machine comes in. The JVM takes the bytecode and makes sure it is run correctly by interpreting and executing it line by line on your machine. Okay, so let's break this down through the three important components, JDK, JRE and JVM. The JDK or Java Development Kit provides all the tools to create Java application, including the Java compiler that converts .java code to bytecode. The JRE or Java Runtime Environment is needed to run the compiled bytecode, which includes the JVM or Java Virtual Machine. The JVM executes the bytecode, ensuring the program runs consistently across different platforms by loading it into memory and linking it with system libraries. So moving ahead with our third question, which is what are the main features of Java? Java is a widely used programming language that's known for being simple, secure and able to run on any platform. It's easy to learn thanks to the straightforward syntax and it avoids tricky concepts like pointers. Java organizes code through objects, which makes it easier to work with and maintain. One of the Java's best features is its ability to run anywhere, thanks to Java Virtual Machine, JVM. Once you write your code, it can run on any system no matter what the platform is. Java also has a strong security with built-in tools to prevent unauthorized access. Plus, it handles memory and errors very well. While Java runs a little slower than languages like C++, it is still very efficient because it compiles to bytecode, which is close to machine code. It also supports multi-threading, meaning it can handle multiple tasks at once, making it perfect for things like web and multimedia application. Java can interact with other languages like C and C++ and even load code as needed, making it a flexible choice for all kinds of softwares. Moving ahead with our next question, which is what is a Java string pool? Alright, let's talk about something very cool in Java, the string pool. Imagine a huge library where all the string values you create are stored. That's what basically the string pool is. Whenever you create a Java string in your code, Java checks if that exact string is already in this pool. If it is, it will just give you a reference to the one that's already there. So you're not wasting memory on duplicates. For example, let's say you create two variables with the same string value like ABC. Java will not store two separate ABC string in the memory. Instead, both variables will refer to the same one in the string pool. But here's the thing. If you create a string using the new keyword like this, new string ABC, Java will store the string in the heap instead of the string pool. As you can see, the string pool helps Java save memory and speed up the string comparison by reusing the same values instead of creating duplicates. It's pretty efficient and a neat way to manage strings in your program. Moving ahead with our next question, which is what are wrapper classes and why they are needed in Java. Alright, let's talk about the wrapper class in Java. You might wonder if we already have primitive data type like int, float or char, then why do we need something called as wrapper class? The answer is that wrapper class provide additional feature that primitives don't have. They allows us to convert primitive type into objects. For example, int is a primitive type, but its wrapper class is integer. By wrapping primitive type in classes, we can use methods like value of or parse int or toString, which gives us more flexibility. This becomes even more useful, especially when working with collections like ArrayList, which can only store objects, not primitive type. A key concept here is autoboxing and unboxing. Autoboxing automatically converts a primitive value into an object, like turning an int into an integer. Unboxing, on the other hand, does the opposite, converting an object back to its corresponding primitive type. So in short, wrapper classes are essential for handling primitive data types as objects, making them more powerful and flexible. When moving ahead with our next question, which is, you're developing an online bookstore where customer can browse a large catalog of books. You need to store and manage different type of books such as list of all available books, a set of unique genre and a mapping of authors to their book. How would Java's collection framework help you efficiently handle these data structures? And why is it important for managing and organizing this kind of data? So imagine you're running an online bookstore with tons of data to manage. A list of all books, a set of unique genre, and a map linking to author and books. Java's collection framework makes this task very easy. First, for all the list of books, we can use ArrayList. Think of it like as a dynamic array that can grow as we add more books. It's perfect for keeping your catalog organized and easy. Next, for unique genre, we would use a hash set. This ensures that there are no duplicate genres, automatically handling any accidental repeats. It's like a super efficient way to store categories without worrying about duplicates. And finally, for mapping authors to their book, a hash map is ideal. It works like a dictionary. Each author, which is key, is linked to a list of books, the value. This makes it super quick to find all the books by specific author. And why is it important? Using collection in Java helps us manage large amount of data efficiently. They provide built-in method for adding, removing and searching, which saves time and make our code cleaner and easier to maintain. So instead of writing complex code from scratch, leverage these powerful tools to focus on building great features for the bookstore. Moving ahead with our next question, which is explain the use of this and super keyword in Java. So in Java, both this and super keyword are specific keywords that help us deal with the classes and objects. Let's break it down. This is used when we want to refer to the current object or the current class. It's like pointing to the object that is calling the method or constructor. For example, the code you are seeing on the screen, in the constructor, this.name refer to the name of variable of the current object and the parameter name is passed to the constructor. And this.name ensures that the value is assigned to the instance variable of the current object. And inside the display name function, this.name is used to access the name of the current object, which in our case is Alice. On the other hand, super refers to the parent or the base class and it is used when you want to access method or variable from the parent class. You can use super to call the parent class constructor or even refer to the parent's class data member and method. So it's like saying I need to get something from the class above me. For example, the code you are seeing on the screen, in the dog class, super.makeSound line calls the makeSound function from the parent animal class before adding the behavior for the dog. To make it clearer, if you are in the child class and want to access something from the parent class, use super. But if you are just referring to the current class or the current object, you will use this. These keywords help organize your code, making it easy to work with both current and parent class elements. Moving ahead with the last question, which is what is the difference between static class method and instance method? Let's break down the difference between static method and instant method in Java. A static method is like a method that belongs to class itself. You can call it without creating an object of the class. For example, you can just call class name.method name. Static method can only access the other static variable and method, and they cannot use this keyword since they don't belong to any object. On the other hand, an instance method belongs to an object of the class. This means you need to create an object first and then call the method on that object. Instance method can access both static and instance variable, and they use this keyword to refer to current object. In short, the key difference is static method belongs to class and they don't need objects to be called, while instance method belong to object and require an object to be invoked. Static methods are good for things that are related to class as a whole, while instance methods are more about operation on individual objects.
So we have already seen some of the basic sets of questions. Now moving ahead with some advanced questions. So what are the constructors in Java and their types? Let's break this down in simple manner. Imagine you are setting up a new flow. So before you can use it, you need to go through initial setup, right? Like setting up your preferred language, connecting to Wi-Fi, etc. So similarly in Java, constructor is kind of like that setup process, but for objects in your program. So it's a special method which is used to initialize objects in Java. And when you create an object from a class, a constructor is automatically called up to set up the object with some initial values. So what are the properties? So some of the properties which a constructor holds is it has the same name as of a class. It has no return type. Constructor do not have a return type, or it doesn't return any value. And it gets automatically called whenever an object is created using this new keyword. And in Java, we have two types of constructor. So a default constructor is also known as no-arg because it takes no argument, and it's like, and if you don't explicitly define a constructor in your class, it gets automatically called up. So for example, for default constructor, here we have a class bike. We have this constructor bike, and it's just returning a simple statement, bike is created. Okay. So this is the example of default constructor. Now let's see an example of a parameterized constructor with a code. So here you can see on the screen that we have a car class. We have this class car with a parameterized constructor taking value of string m and int y. So, and here we have a constructor class which is taking parameters of type string and int, which is being assigned to model and hero. So whenever you are creating an object with different values, say for example car and car1 object, and whenever you are assigning values of m to Tesla model and y to 2022, so the same value is being assigned here also. So whenever you will run this program, you will see after calling this display function, then you will see the values as, say, model is Tesla and year is 2022. Based moving ahead with the next question, which is explain the difference between string buffer and string builder. So imagine you have a string in Java and you want to modify it multiple times, like adding words or changing its content. In Java, there are two classes that help with this, which is string buffer and string builder. So now talking about string buffer. So string buffer is a synchronized, that is thread safe. It means two threads can't call the method of string buffer simultaneously. Which means if multiple threads, you can think of it like different people working on same project and are working on the same string. Then string buffer will make sure that they don't mess up with each other works. So in like operating system, you all must have went through mutex, right? So mutex, like locking of a resource whenever one process is acquiring that resource. Similarly, in case of string buffer, if one person is accessing one object, then no other person can access that same object. So because of this property, it is slower because it makes sure that everything is safe. And when many threads are involved, it's a bit slower than string builder. On the other hand, talking about string builder, It's a non-synchronized. Now talking about the string builder is non-synchronized, that is not thread safe. It means two threads can call the methods of the string builder simultaneously, which makes it more efficient than string builder. So if multiple threads try to change the same string, like if P1, P2 and P3, they try to change the same string, they can change it. But that's usually fine like when you're working in a single threaded environment. Okay, so here on the screen you can see that this is a Java program which demonstrates the string buffer class. So here we are creating a new string buffer by using this string buffer. We are creating a new string buffer. Now let's see the string builder. Similarly, here we are creating a new string builder by using string builder str equals to new string builder and passing out the values. So you understood, right? So if you're working with just one task at a time and need something quick, you should go for string builder. But if you're working in a situation where multiple tasks are changing, you should go with the string buffer. The next question, which is what is the difference between abstract classes and interfaces? So abstract classes and interfaces in Java both allows us to define methods and subclass must implement. So in Java, abstract classes and interfaces allows us to define method that subclasses must implement, but they serve different purposes. Okay, so this is the example of an abstract class. Here are two classes, circle and rectangle, and this shape is extending. So in this abstract class, this circle and rectangle extends the properties of shape, wherein in interface, this circle and rectangle implements the properties of the shape. Let's see in more detail. So abstract classes can have both abstract and non-abstract methods. It supports only single inheritance, and it can have various types of variables such as final, static, and non-static. Talking about the implementation, it provides some implementation details. And it can extend other classes and implement interfaces. Talking about the interface, it can have only abstract method. It supports multiple inheritance, and variables are public, static, finals, or by default constant. It cannot provide implementation and only method signature, and it can only extend other interfaces. Right. Let's see this through a code. So let's see. Here you have a public abstract class shape, which carries both abstract method, this void drop, and non-abstract method move. But whenever you will talk about this interface drawable, it only consists of abstract method. Okay, so this is the basic difference between these two. I hope now you're clear with. So here you can see we have a abstract class shape, and we have an abstract method void drop, and we have a non-abstract method void nil, and one print statement. So you can see in abstract class, we have both abstract and non-abstract method, but in interface, we have only abstract methods and no non-abstract method. So this is the basic difference between an abstract and the interface. Moving ahead with our next question, which is what is method overloading and can we overload the main method? Okay. So method overloading in Java allows a class to have multiple methods with the same name, but they should differ in number of parameters and the type of parameters or both. Okay. Which is a feature of polymorphism where the same method can perform different tasks based on the input provided. It's a way to make your code more flexible and easier to understand. And now talking about can we overload the main method? Yes, we can overload the main method, but there's a catch. The main method is special because it's an entry point of Java application. You all agree, right? And the JVM looks for the main string.err method to start your program. Even if you overload the main method with different parameter, the JVM will only call the original string argument method. Okay. Now let's see an example through the code. As you can see here, we have a public class overloading. And this is overloaded main method with an int parameter, int_r. Okay. We have overloaded this main method with another parameter, $r, and this is your original main. Now we are calling the overloaded method from original main. We're passing the value according to the parameters. So here we are giving argument 5 and here we are giving argument 3.14. Now let's run this code. So whenever we are passing here the arguments, accordingly, the value is being displayed, right? Moving ahead with our next question, we have explain method overriding and its restriction on static and private methods. So method overriding occurs when a subclass provides a specific implementation of a method already defined in superclass. Okay, and the method in the subclass must have the method signature same, like name and the parameter should remain the same, right? So method overriding is a key concept in Java which enables a runtime polymorphism. And what we just talked about, like overloading the main method, it's an example of compile type polymorphism. Actual method executed is determined by object's runtime type, not just the reference variable type. Okay. So here we have a parent class and a subclass. And suppose we have two methods here, move and edit, and suppose this move is being inherited by this dog class, then this move will have its own implementation and is known as overridden methods. Okay. Now let's see this with the example of a code. Okay. So now talking about this, we have a class animal, which is a base class with some of the methods like move and eat. We have a class dog, which is extending the properties of animal, and this dog has its own move. And in this, it has dog is running. So now whenever you will call this function d.move, then this class will have its own implementation. That means it will be showing that dog is running instead of saying that animal is moving. Why? Because this class has overridden the properties of this animal class. So that was the basic idea of method overriding. Now talking about the restriction on starting in private method. So overriding methods access modifier in a subclass can be more. So we cannot override the static method because method overriding is based on dynamic binding at runtime. Okay. So that's the reason we can't override the static methods. So moving here to the next question, which is how is exception handling done in Java? So what are exceptions? Suppose here you can see on the image, a girl is watching a video on YouTube. Okay. And all of a sudden, the Wi-Fi gets disconnected. Then what will happen? It will be interrupted in watching video due to internet disconnectivity. And there will be a message shown here like, no internet, right? Similarly, exception handling in Java is a mechanism to handle runtime errors, ensuring normal flow by using try-catch block and other related constructs. So that suppose you have 10 lines of code and one exception comes here. So if there is a specific block of code in Java to handle this exception, and which will make sure that your normal flow of the program is there. Okay. So how is exception handled in Java? Suppose there is a program code. If the exception has occurred, yes, then it will go to try-catch block. And if the exception is handled, the finally block is executed. And if it is not, then also the finally block is executed if there is no exception. So what is try block? It contains the code that might throw an exception. What is catch block? It captures and handles specific exception. and multiple catch blocks can be used for different type of exception. Okay, for example, you all know that 10 by 0 will give you an exception. Okay, so this will go in the try block. Okay, and the catch block will handle the exception. South, it will print can't divide by 0, right? And then comes the finally block, which is always executed whether the exception is there or not. So there is some line like this block is always executed regardless of the exception. So together these blocks ensure that program can handle errors and continue running. Moving ahead with our next question, which is what do you mean by life cycle of thread in Java? So life cycle of thread in Java refers to various stages a thread goes through from its creation to its termination. It's same as of in operating system, a process goes through multiple stages. For example, the new state, when you create a thread but having started, runnable. Once you call the start method, okay, the thread moves to runnable state, and in this it is ready to run but may not be actively running, right? Now talking about the running state. So after this runnable state, the process finally goes into this running state, and in this the process is now has acquired all the required resources and is ready. So now talking about this blocked waiting and sleeping state. So in this, the process has gone for IO request and is blocked for some amount of time. And finally, we have terminated state. The thread ends when its task is completed. So understanding these state help manage thread effectively in Java, ensuring smoother multitasking and synchronization. Moving on with the next question, which is what is a singleton class and how do we create it? So a singleton class in Java is a class designed to have only one instance or object throughout the entire program. So suppose this client 1, client 2 and client 3, this will have a single instance of this function throughout. Okay, and the main idea is that no matter how many times you try to create a new object, always get the same instance, which ensures control access to resource such as database connection, where having more than one instance could lead problem like wasting memory or causing conflicts. So to create a singleton class in Java, we follow the step like prevents direct instantiation. And to create singleton class in Java, we follow the steps like private constructor, which is made private to prevent other classes from creating new instance. Okay, so the constructor is defined as private, not public. Static method, usually get instance, is used to provide the global access point for the single instance, which this method checks if the instance already exists. If it doesn't, it creates a new one. Then we have third static instant. Then we have thirdly static instance variable. In this, repeat, the instance is stored as a static variable, so it's shared across all calls to instance. So moving ahead with our next question, which is what is difference between aggregation and composition in Java? So in Java, when objects are related to each other, there are two types of relationship, which is aggregation and composition. You can think of aggregation as a relationship. For example, imagine a department in college. A department has students, but those students can exist without department, right? The students have their individual identities. And if the department is removed, the student can still exist or move to other departments or leave the college. This means they are not tightly bound together. Similarly, talking about the objects, it can exist independently in aggregation, and the child object can outlive the parent, and it is used when objects have their own life cycle. Whereas talking about the composition, so composition is more dependent form of aggregation, and it has a part of relationship. For example, think of library as its books. If the library is destroyed, all the books inside it are also destroyed, and the book cannot exist without library. In composition, only one object like library owns the control the life cycle of other. Repeat, in composition, so we can say in composition, one object like library controls the life cycle of other object like a book. Okay, so a book is a part of library, and without the library, the book can't exist. Similarly, child object depends on the parent object in composition, and child objects are destroyed with the parent. And it is used when objects are strongly bound together. So in summary, you can say aggregation is more like a relationship where one object contains another, but both have their individual identities. On the other hand, composition is where one object fully controls the existence of other. Moving ahead with the next question, which is what is an anonymous in a class? Imagine you want to create a quick one-time use helper in your Java program like a disposable tool. That's where anonymous in a class comes in. So an anonymous in a class is a class without a name that is defined and instantiated all at once, typically used for implementing interfaces or extending classes in a one-size way. So talking about the properties, it doesn't have a name, is used to override method or add extra behavior, and only one object of that class is created. It helps simplify code when you need a quick custom implementation, and it saves time and space by avoiding creating a separate class file. Okay. Now let's see a simple example for the same. So you can see here the code on this repeat. So you can see the code here on the screen is a simple example. We have interface age, then void get age. Then we have using anonymous in a class. So here instead of creating a separate class that implements age, we create anonymous class in the main method. This makes the code compact and easy to manage. Okay. So key pointers, single implementation, no constructor. You can't define a constructor because class has no name. And local variable, it can access local variable of surrounding method, but they must be final or effectively final. So in the given code, the age interface, this age interface is implemented using an anonymous class, which is created during the instantiation of age. In the statement, age object is equals to new age. Here the new age part indicates the creation of the anonymous class, and the implementation of get method inside this get age, inside this, provides its behavior. This anonymous class does not have a name and is directly override the get age method of the age interface when obj.getAge is called. The overridden method on the anonymous class is executed printing age is 21 with a console, right? So we don't have a name here. And as soon as this new object is being created, the anonymous classes automatically get called. Okay, moving ahead with our next question. Explain the difference between implicit and explicit type conversion. So type conversion in Java is like changing the shape of data to fit different containers. Okay, imagine pouring of water from a small glass into a larger one. It's automatic and easy. But if you pour into a smaller glasses, you might spill some, right? So you have to be more careful. And this analogy helps explain implicit and explicit type conversion. Now talking about the implicit type conversion, it's an automatic conversion of a smaller data type to a larger data type by the compiler. So the Java compiler does this when it's safe to do, like when you are moving data from a smaller container to a bigger one. So this int is of course smaller than this double, so it automatically get converted into a double. Here Java see that int can easily fit into double, so it does. So the advantages is it's convenient, you don't need to write extra code, and it's automatic. As the Java compiler see, it does it. Now talking about the explicit type conversion, this is the process where the programmer manually converts a variable from one data type to another. So, for example, you have a double big num and you want to convert it into int. So here you will write the int num, and then you will convert. So you will have to manually convert double into int because Java compiler is not going to do it for you. So the advantage is control. and clarity. Okay. So by understanding these two approaches, you can write more error-free Java programs and handle data conversion. 20th question, which is, what is the purpose of a volatile keyword in Java? So the volatile keyword in Java is used to ensure that changes made to a variable in one thread are immediately visible to all the threads, preventing threads from caching the variable and ensuring consistent access across multiple threads. Okay, so without this volatile, if one thread updates the variable, suppose one thread is updating this variable x, the other thread might not see the change right away because each thread could keep its own local copy of the variable. And using volatile tells the JVM that the variable's value will always be read from and written to the main memory, not from thread's local cache. Okay, which ensure that all threads see the most recent value of the variable. So suppose if there is one variable, this counter is accessed by thread 1 and thread 2. So if any changes is made to this counter, it will immediately be reflected to this counter also. And that is what the purpose of volatile keyword is. So in summary, we can say that we use volatile when we need threads to see the latest value of variable immediately, but don't require the atomic operation. And what I mean by atomic operation is something like x equals to x plus 1. These are all the atomic operation. It's a lightweight alternative to synchronization for visibility purpose. So moving ahead with the next question, which is, what is the difference between system.out, system.err and system.in? So in Java, system.out, system.err and system.in are the standard streams for handling output and input in console-based application. Okay. So here is your console for printing anything. These three are used. So now talking about the purpose, system.out is standard output for regular message, system.err standard output for error message, and system.in is the standard input for reading user inputs. Okay, so hello world. It's for displaying a message. Read system.err. So system.error.println if any occur has occurred. Again for system.in, it's like the often combined with classes like scanner class for taking the user input. So here's the syntax for all the three: system.out println error, and for taking the user input. So these three streams helps in debugging and managing console interaction efficiently. Moving ahead with the next question, which is, what are the access specifiers in Java and their purpose? This is one of the most commonly asked question in interviews. So as we all know, there are three main access specifiers in Java, which is public, private, and protected. So what is a public? When you define any class to the public, that class is accessible from any other class, and it is used when method or variable need to be accessed globally. Okay. So if a class is defined with this private keyword, it is accessible only within the class where it is defined, and where it is used to protect sensitive data and encapsulate implementation details. Now talking about protected, so it is accessible within the same package and by the subclasses. So any subclasses also can inherit or can access the data members and member functions, and it balances between public and private, allowing limited access. Okay. So suppose there is so talking about the implementation of all these three, you all know that public is just defined using this public keyword, and all the other classes, class A, suppose there is a class B. So class B can access the properties of class A when it is defined publicly. Okay. Okay. So now talking about the private. So if there is a class A with private void display. Okay. Suppose there is a message south hello. Okay. And if there is another class B, okay, here this object is created, obj equals to new A, and when this object will try to access this display, which is privately defined in this class A, your system will throw a compile time error. Okay, when trying to access the private member. Moving ahead with the next question, which is, do finally and finalize keyword have the same function? So the answer would be no. The keyword finally and finalize in Java do not serve the same purpose, and they are used for different uses. So now talking about this final keyword. So the keyword final is all about restrictions. You can make it to restrict the user from changing the value of a variable, from extending a class, or for overriding a method. So if
you have a variable defined with final keyword int x, suppose it is 10. So when we will assign this variable x to 20, a error will be thrown that it cannot be reassigned because this is assigned with the final keyword. Moving ahead with finally. So the finally block is used in exception handling. Okay. And it ensures that certain code always runs whether or not an exception has occurred. For instance, it's often used for resource cleanup like closing files or database connection. Okay. So suppose we have already discussed there are try and catch blocks for exception handling. So suppose there has occurred some exception int x equals to 5/0. You all know this is an exception case. So it will be in try block. Okay. So catch will catch the exception E, and the finally block will always run regardless. This will always execute regardless of the exception has occurred or not. Suppose instead of 5/0, so instead of this 5/0, if your statement would have been something like int x equals to 20/5, then also this finally would have been run. Okay, so no matter what, this block will always run. Now talking about this finalize. So the finalize method is called by the garbage collector before an object is destroyed. Okay, allowing cleanup tasks like releasing the resources. However, it's rarely used in modern Java due to better alternative like try with resource example. Okay, so this is called when we want to clear the object's memory. So in short, we can say finally sets restrictions. This finally sets restrictions. This finally it ensures cleanup after the exceptions. And this finalize is for cleanup before garbage collector. Right?
So moving ahead with the next question, which is, a string is given. Our task is to write a Java program to toggle the character of the given string. For example, for the string, the string after toggling will look like this. So all the caps will be converted to lowercase and all the lowercase will be converted to uppercase. Okay. So what our pseudocode will be? So we'll be reading the input string. Okay. This one will be initializing an empty result. Okay. We'll be initializing a variable for creating the result. Then we'll be having a looping statement to go through each character of this string, and we'll check if character is uppercase. Suppose if this S is in uppercase, it will be converted to lowercase and it will be appended to the result. The result variable which we'll make here is if character is in lowercase, the CH will be converted to uppercase and it will be appended to the result, and then the output will be printed. Okay. So let's see the Java code for the same. So here we are creating the scanner object. Here we are asking for the user input. We are reading the string input from the user, storing it into var2. Then we are closing the scanner, then creating the string builder to build the toggle string var3. Then we are converting the input string into array of character. Then here we are getting the length because we have to put the looping statement. Okay. So we are putting the looping through each character of the input string. And here the if else condition for checking if it is in uppercase, it will be converted to lowercase. And if the character is in lowercase, it will be converted to uppercase. And append it to the result. Okay, so var3 is your result. And here the last console we are printing. Well, let's run this code. So let's run this code to see the result. So yeah, so suppose we are writing the string string. So you're seeing this capital S is being converted to small s and the rest like that only. So this was all for this particular question. So moving ahead with the next question, which is calculate how many times a digit D occurs in the number n. One has to ask the user to give the values of n in D. Okay. Okay, so suppose this is a number 1, 2, 3, 4, 4, 6, 5. So our task is to find, suppose 4. how many times this 4 has occurred in this particular number. This is our task. Okay. So what is the pseudocode? We'll be reading the number n and d. Okay. Initializing set will be making one count variable here, count, and we'll be setting it to 0. Then our looping statement will be there while n is greater than 0. Okay. And then we'll extract the digit by using this modulus. And we'll check if the extracted digit is equals to d. We'll increment the count. And we'll reduce update to n by 10. Then we'll update this n by dividing n by 10. Each time we'll do this, we'll remove the last digit and then we'll print or return the count. Okay. So let's see the code for the same. So here's the simple code for the same. We are making a function to count the occurrence of digit d in number n. This is the name of your function, count digit occurrences. Parameters n and d. Here we'll be taking the n and d from user. This is the looping statement. Every time this is checking if n mod 10 equals to d. Every time we are incrementing the count, and here we are returning the count. Okay. So let's see by running this code. So suppose 1, 2, 3, 4, 4, 5. Okay. So here it's showing that digit 4 occurs 3 times in this particular number, right? So you must practice this code because it is asked in many interviews. Moving ahead with the next question, which is print reverse array in Java using recursion for the given input array without using any extra space. Okay. O of 1. Ignore the implicit stack function overhead. We have to ignore using recursion for computing the space complexity. Okay. Right. So we have to reverse the array. Suppose we have an array 1, 10, 12, 13. Then after reversal, we'll be having 13, 12, 10, and 1. Right? So we will be making a reverse array. This is a pseudocode. Then that function will take argument as array, start, and end. Base case will be if the start is greater than or equal to n, return. Okay. So there is no element or only one element is present in this array. We have to return. Then we have to swap array of start with array of n, this one to this one. And then again, we'll call this reverse array by passing array start plus 1, meaning if initial start is here, it will be passed to here. And if the end is here, it will be coming to here. Okay. And in main function, we'll define an array of ARR. We'll call reverse array by passing initially array 0 array.length minus 1 function. Okay. And then we'll print the array. Simple. Let's see the code for the same. Okay. So this is the code for your reverse array. This is the recursive function. We are passing array start n. This is your base case. If the start becomes greater than or equal to end, we'll return. Then we are swapping here the elements. Okay. Then again, this recursive call is being called. Okay. Nice. And here we are printing the reversed array. So let's run this code to see if this code is working or not. Okay, enter the size of array, say 4. Enter the number of elements, 1. Enter array elements, okay, 1, 14, 4, 6. So the reverse array will be 6, 4, 13, 1. Yeah, the code is right. You may check it by running it into your VS Code or by practicing it on to Leak code. So moving ahead with the next question, which is write a program to check if the strings are anagram. Okay. So anagram strings are something that have same characters with same frequency, but the order of character is different. For example, if you have two string S1, which carries act, and S2, which consists of tag. So the frequency of A is 1, C is 1, and T is 1. And in S2, The frequency of T is 1, A is 1, and C is 1. So you can see the order is different, but the frequency of occurrence is same. So that's called the anagram string. So what will be our approach towards this question? We'll take an input, we'll take two words, we'll check the lengths. If the word have different length, they can't be anagrams. Okay, fine. So it's pretty simple that if there is a difference in length, string will not be in anagrams. So we'll stop there and we'll say they are not anagrams. Then we'll convert to character. Then we'll break both words into individual letters. Okay. Then we'll sort. We'll arrange the letter in alphabetical orders. Okay. Then we'll convert to character. If the sorted version of both words match exactly, they are anagrams. Otherwise not. And then we'll display the result. You can also do this using this map. But we'll not use map for this particular question in our program. So let's see the implementation. Okay, so you'll see. So we are taking the input. We are asking for the first and second string. Okay. And we have made is anagram function, which will check if this we have made this is anagram function, which will check if the strings are anagram or not. So it's simply checking if string 1.length is not equal to string 2.length, it will return false. Otherwise, it will convert it into characters and then it will sort it and then it will return array. If it is equal, both the arrays are equal, then it will return true. Okay. So here it's checking if it is anagram, it is returning the strings are anagram. Otherwise, the strings are not anagrams. Let's run this code. So enter first string, tap, tap. The strings are anagram. Okay. Moving ahead to our next question, which is write a Java program for finding the index of the first as well as the last occurrence of an element in an array using linear time without using the extra space. Consider one indexing. Okay, so suppose you have some elements 1, 1, 2, 3, 1, 4, 5. Okay. And if I want to find the first and last occurrence of this one, so the first occurrence is at 0th position and the last occurrence of this particular one is at 0, 1, 2, 3, 4th position, right? So what will be our approach? We'll define an array and target number, okay? I will set first and last index to -1, okay? So suppose we don't know where does it exist, so we'll set it to -1. Then we'll loop through the array. If the number matches, we'll set first index if not set, and we'll update last index each time. And then we'll print the result. If the first index is -1, fine, it is never found. So if this doesn't get incremented anytime during your program, the target is not there. Otherwise, we'll print the first and last position. Let's see the code for the same. So the program scans an array. We have already defined the array here, okay? To find the first and last position of the given number, it starts by initializing two variables, var2 and var3 by -1, indicating that the number hasn't been found yet. Then it iterates through the array, checking each element. Okay, here it is iterating. And when it encounters the target number for the first time, it will set this var2 to var4 plus 1. Okay. Regardless of whether it is the first occurrence or not, it continuously updates last index to store the most recent position. Okay. And after finishing the loop, it checks if the first index is still -1. So after finishing the loop, it will still check if the first index is still -1. It will throw a print statement that element is not found in the array. Otherwise, it will display the first and last occurrence of that particular element. Okay. So let's run this code to see the output. So you see that the first occurrence of 3, because our target was 3, This one is at index 2 and the last occurrence of 3 is at index 7. Okay, so that's all for this question.
Here with the next question, which is, apart from security aspects, what are the reasons behind making strings immutable in Java? So string in Java are made immutable for several practical reasons beyond security, and this design choice significantly improved the efficiency. So for efficiency and reliability of the language. So talking about the string pool. So first is string pool optimization. So strings are used extensively in Java, and creating new objects for every string would waste memory, right? So to optimize this, Java uses something called as string pool. So a specific area in memory where string literals are stored when you create a string. Java checks the pools to see if the string is already there. If it does, the reference is used. Just the reference would be used for that string for creating a new object. And this sharing is only possible because strings are immutable. Okay, because of this immutable factor. Modifying one string would accidentally alter others. So this sharing is only possible because strings are immutable. And if the strings were mutable, modifying one string would accidentally alter others, breaking the program, right? Second is multi-threading or thread safety. So strings are commonly shared across multiple threads in application. Since immutable objects cannot change state, they are inherently thread safe, meaning you don't need additional synchronization to protect them. And this simplifies multi-threaded programming and makes your code cleaner and less error prone. Now talking about this last one, collection. So reliable hash-based collections. So strings are widely used as key in collection, like hash map. So you must have heard about this hash map. So key value pair exists in this hash map. So if the strings were mutable, their hash codes could change after being inserted into the map, okay, leading to data corruption or retrieval failure. Immutability ensures that consistent behavior and reliability is there. So by making strings immutable, Java achieves optimization, thread safety, and reliable data management. Okay, moving ahead with our last question, which is, what is the difference between deep copy and shallow copy? Okay, so deep copy creates a new object and copies all the field, ensuring that changes made to one object. Suppose there is object X, and if any changes are made in this object, don't affect the other object. So in a very simple language, suppose there are two friends, okay, they do have their separate piggy banks. So if this friend adds 2 coins to his piggy bank, this particular friend's piggy bank doesn't get altered by his savings or his coins, right? So this is something called deep copy. So each time new memory is allocated whenever the object has. So what's about the memory impact? New memory is allocated. Each object has its own independent reference. Okay, let's see it with a very simple code. So suppose there is one class, okay, A, and we have a variable int x assigned 30, okay, and there is another class B. I'm not writing the return type, and here what we are doing, we are creating the object of this class A obj1 equals to new A. Okay, so what it will do, it will just copy the reference, not the value. Okay, and we are creating another object obj2 equals to new. Okay, and now what we are doing, if we are obj.2, if we are modifying this x value to 6, right, and we are printing the value of obj1.x. So south obj1.x, okay, and if you are printing this value, we will see that the value of x this program will return will be 30, because it is just copying the reference and not the original value. Okay, so this was all for the deep copy. So moving ahead with what is the shallow copy. So shallow copy refers to the copying the reference of an object, not the actual object. and changes made to one reference will affect the other. For example, these two are sharing the same cupboard, and if one modification is made from his end, it will also reflect when he will open the same cupboard. Okay. Talking about the memory impact, no new memory is allocated. Both reference point to the same memory allocation. Okay. So the only difference is that here we are creating the object 1 equals to new A, and when this object 2 will be created, A obj2, it will be assigned to obj1 like this. And when this object 2 will update the value of x to 6, and when this will be printed, object dot 1x, the value will be 6. Okay. So because both the reference are pointing to same memory allocation. Understood? So that's all from my side. If you guys like this video, kindly hit the like and subscribe button for Intellipaat's YouTube channel. Thank you and see you in the next video.